Okay, here's a weird one. Pi to the x equals x to the pi. Yeah, I know. It looks symmetrical, but it feels like it shouldn't be. Let's poke it. First guess. What if x is just pi? I mean, that would make both sides the same, right? Except, no. If x equals pi, then pi to the pi is huge, and pi to the pi is still huge, but not equal huge. Too big on one side. Goldilocks would not approve. Okay, wait, hold on. What if x is 1? Pi to the 1 is pi, but 1 to the pi is still just 1. Way too small. Goldilocks strikes again. So maybe there's a sneaky value hiding between 1 and pi, some number that balances both sides perfectly. And here's the twist. There's not just one. Okay, let's bring everything back down from the clouds for a second. These exponents are doing acrobatics, and I think we need to pull them to the ground. Let's take the natural log of both sides. Now, using our log rules, the powers slide down to the front. Much better. Suddenly, life makes sense again. All right, here's the part that always feels weirdly satisfying. We just divide both sides by x times pi and let things settle for a second. And then something kind of magical happens. Those huge, intimidating powers you saw a moment ago, they just fold in on themselves. Like the equation suddenly remembered it doesn't need to be dramatic. What's left is this clean little balance. ln of pi over pi equals ln of x over x. Simple, quiet, almost calming. Okay, so once we land on this little expression, the game changes. Now we're just looking for a value of x that makes ln x over x match that constant from the pi side. And if you've ever stared at that curve before, you can almost feel where the answers might be hiding. One of them is kind of obvious. The other one, not so much. Which makes it more fun, honestly. First one's easy. X equals pi. It's basically waving from across the room like, hey, yeah, it's me, pick me. But there's a second solution tucked deeper in the curve, a quiet one. If you set ln x over x equal to ln pi over pi and follow that line back across the graph, you bump into x equals e. A little unexpected, but it fits perfectly. So in the end, this whole equation, pi to the x equals x to the pi, doesn't give us one answer. It gives us two. X equals pi and x equals e. And there's something really pleasing about that. Like the math had a secret partner the whole time and finally decided to introduce them.